Hello, in this lesson, I'd like to go over questions that in our homework using substitution method to integrate. And in particular, in this lesson, we're going to do indefinite integral by substitution method. And we know that substitution rule is assuming that g is a differentiable function and, whose range is an interval I and f is continuous on I. So the domain range matches perfectly. And then the integration of f on g as a composite function and u, which is equals to g of x, right? So we know that du, the derivative of u is the derivative of u with respect to x with dx is g of x, is g of x. Okay. It's g prime, sorry, g prime, right? That's a derivative of g. And as a result, we multiply both sides by dx, du equals to g prime dx. In other words, this is a du. This is a du. So that's how we get a du. And so this substitution simplifies the function. And so you can see when we are doing different integration by substitution, on the left-hand side of this expression of integral, indefinite integral, everything was expressed in terms of x. On the other side, everything was expressed entirely in terms of u. So this change is called a substitution. And then, of course, usually we will be able to finalize the substitution to get the result. In this lesson, I will go over questions from easy to simple to more complex. And I also want to show you how to show work, okay? But I also recommend that before you watch each question, you may like to put a pause and then try it on try it by yourself. And the bottom line is eventually after practicing so many questions, you'll be better prepared, not only for the final exam, which is coming up, but you're also better prepared for your math, for calculus 2. Okay, so let's get started. Okay, the first one, the assumption, or we have, we have indefinite integral of cosine of 2x. And we know that we know the antiderivative cosine x, right? So what's the antiderivative cosine 2x? So in this case, we would introduce a variable u, which is equal to 2x. Okay. And then we will need to change everything from x to u. So we will need to know what will be du. Du would be equals to 2 times dx. So dx will be substituted, right? 2x will be substituted by u, and 2 times dx equals to du. We don't have 2 times dx, right? So we can also, the other way that make it easier is to express x by dividing both sides by 2. So we get half of du. Okay, so by this time, we can carry out the substitution. Okay, the integration sign will come, and we'll get cosine u, and dx will be substituted by its equal, so half of du, half of du. So this piece is entirely in terms of u, and the given expression is entirely in x. So by this time, we have completed the substitution part, and then the next part is the substitution, is integration. And the result of this integration usually would be that it's much easier to integrate. Okay, so we get a cosine u, du, and the antiderivative of cosine, right? So we're gonna work on the antiderivative of cosine. Then you'll be thinking, what function takes derivative equals to cosine u? And that's going to be sine of u. So 1/2 and sine of u, okay, plus a constant. And we're not finished. We're not finished because we need to substitute u by in terms of x. So the last step would be we're going to replace u by 2x. And to check our answer, right? To check our answer, you just have to take a derivative of the result, and we should get a cosine 2x. Okay, so by taking derivative of the result, right? So we're taking derivative of the result, and then we're gonna get half, right? The derivative of sine 2x, we're gonna apply chain rule, so it's a cosine 2x, the derivative of 2x is 2, and the derivative of constant is 0, so we got cosine 2x. So that has verified by chain rule, the answer is correct. And from this example, you can also see that this integration by substitution actually is a reversal of using the reversal of chain rule. Okay, reversal of chain rule. All right, so second question. Okay, so I'm going to bring this with us. Okay, bring this with us for, just for reference, because, and also we want to show these work. The way we show the work is that you either entirely in terms of x and entirely in terms of u. And if you put these part of work, I wish you to be separated, right? So on your paper, you will have 2 parts. You have 2 parts, okay? So on your piece of paper, you will have this whole piece of paper, and part of it, half of it is to show your work in this manner, preferably, and your substitution is done on the other side. Okay, you can choose to decide which, how it's in the middle, 1/3, 2/3, depends on your need. Okay, so that's what I recommend. That's what I recommend to make it clear. Okay. All right, so let's look at the second one. The second one, to integrate, I would introduce a u equals to negative x squared. Okay, so this will be entirely replaced by u, and the derivative of u will be negative 2x dx. Okay, so in this expression, sometimes people like to move the term around. You can move the x in front of dx, right? So you can do this kind of just moving things around so that we can see clearly that this part will be substituted by e to the power u, right? This part will be substituted by e to the power of u. And the next part will also need to be substituted. So that's why sometimes we will show to the reader that x times dx equals to negative 1/2 by dividing both sides by 2, negative 2 du. Okay, so this, you can see the substitution on the dx part and the substitution on the function part. So this will be u, and that part will be replaced by these. In this case, we should have a parentheses for negative 1/2. unless you put a negative half in the front. Okay, if you put negative half in the front, you don't need a negative half. Okay, so by this time, the integration can be done pretty quickly, and we are almost done. Okay, this step is optional. Okay, this step I'm going to mark it as optional. Okay, you can show it explicitly or implicitly, right? Because you can also see it as x times dx, right? X times dx. So this is how you show the substitution. But there are some flexibilities you can show your work, okay? And the antiderivative e to the power u with respect to u is e to the power of u plus a constant, And in the end, we will have to bring back the u in terms of x back in place. Okay, so that this question is done. And you can feel free to check it. For the following questions, I'm not going to check all of them for, to save time, okay? Because I don't want to make this lesson exceedingly long, okay? So let's look at number three. So along the way, you start to learn some techniques. Which is needed for your, for your continued study in calculus. And in this question, I'm going to assume introducing u is a trial and error. It's a process of trial and error. So feel free to use your scratch papers to try things out. Sometime it may not work. Try something else, okay? So when you're trying it, do not be discouraged if you don't find it right away. So now I'm going to show this part, and the u, okay, the derivative of u would be 3 times x squared dx. All right, so you can see we have a square root of u, right? The next step we're going to do our substitution. So this will be square root of u, x squared times du. I'm sorry, x squared times dx, right? X squared times dx. We can find x squared times dx, which is going to be 1/3 of du. Okay, in this relationship, divide both sides by third. Divide both sides by 3. Du. So this part will be substituted by its equal in terms of u. So this way, the substitution is finished, right? The substitution part is finished. And the next part, you're going to do integration. I always move the constant outside. For, for convenience and simplicity. Okay, for convenience and simplicity, because you want to keep it as simple as possible, as clear as possible. Okay, and then you'll be working on the antiderivative of square root of u, right? And that's going to be 1 over, you probably know this very well, right? Plus 1. And u raised to the power of 3/2. And of course, plus a big constant, right? And next, we're going to simplify this. And that's going to be 3/2, right? So that's going to be a 3/2, right? And one more step, or you can just go straight to the next step, which is going to be 9/2. Okay? And don't forget to substitute u, okay? Substitute u in terms of x to finish the question. And that's it. Okay? The next one, we're going to see a trig function. Trig function, okay? Substitution involves the trig functions. Okay. In this case, feel free to experiment, but I'm going to just get started. U equals to sine x, sine theta. And U would be equals to cosine theta and d theta. Okay, because du d theta equals to cosine theta, right? All right, so cosine theta times d theta, so that would be just du, right? So you can see this substitution. Once you have introduced the right expression, right? So this part will be just u squared. And that part is du. All right? Equal to the antiderivative of u squared is 1/3, and then it's u to the power 3, and then plus a constant. Last but not least, we're going to bring back the u, right, which is sine theta. So it's going to be sine to the power 3 theta. Done. Finished. Okay? So be brave and be, do not be afraid. Just try your way. You will eventually, by practicing as much as you can, and you will master it. You will master it for sure. Okay? It just takes practice. It just takes practice. All right, on this one, I will be introducing u equals to the entirety of the denominator. Okay, so by this time, you probably have seen the hang of it, because the derivative of the denominator will be 1 degree lower than the degree 4. So it will be get to the level of degree 3, right? So then du would be equals to 4 times x raised to the power of 3 dx. All right. So that way, right? So we're going to I'm going to show you. So x raised to the power 3, I'm going to bring this with dx, right? So this need to be substituted something, right? So we got something here, right? So x raised to the power 3 dx, and if you divide both sides by 4, and we will get a quarter multiply du, because all we do is on both sides, we're solving for x raised to the power 3 times dx. So this part is u, okay? X raised to the power 3 times dx is a quarter, is replaced by a quarter times du. So that's how the substitution is done. And let's finish. Okay. Finish. We're gonna bring the constant 1/4 outside, and the antiderivative 1/u is ln. Okay. Shall we take absolute value? Well, u is a function of x, and the domain is all real numbers. And the entirety of this function is all real numbers. As it can be positive and negative. So in this case, we should be using absolute value of u and plus a constant. So last but not least, we're going to finish the work of substitution, bring back x raised to the power 4 minus 5 to substitute the u. So that's finished. Okay. So let's look at number 6. Okay, so you guys see how work is shown, how substitution is done, right? And practice, 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 okay? Practice makes perfect, okay? All right, the next question. How are we going to introduce the U by trial and error? But by this time, you probably have gained some experience, right? So here I'm going to introduce U to be the entirety under the square root, okay? And the derivative of U would be, the derivative of 1 is 0, the U is going to be negative 1 over x squared dx. And we got a 1 over x squared dx. You see that? Right? So 1 over x squared multiplied dx is equals to negative du. Right? So you work on this expression and solve for the part you need. So now we go back to the function. Okay, just make the separate, make the substitution part separated. And then we're going to do the substitution. I'm going to show you, right? So this piece is u, and 1 over x squared, I'm going to move it next to dx. And this piece is that piece is negative du, is negative du. So this piece will be replaced by negative du. Be sure that you have the parentheses. Unless, because if you don't have the parentheses, and that's what you show, that's a mistake, okay? So you either show it this way or bring the negative sign in the front. Okay? And the next step will be just finding the antiderivative. We have seen one case of finding antiderivative of square root of u before, so let's just do it again, right? So it's 1 over 1/2 plus 1 u raised to the power of 3/2 plus the constant, right? And the next step, simplifying, right? So this is going to be 3/2. So 3, 2 moves, flip over to the front, and u will be substituted. We can do it the next step. U will be substituted by the entirety of u in terms of x. And that's done. That's finished. Okay. So you can see we use a derivative, we use substitution here, chain rule to check your answer. All right, so let's look at the next question. Number 7. Number 7. Right? So this is how you show your work. This is how you show your work. The other half, you write down the substitution and whatever you have derived. All right, on this question, okay, I would introduce u equals to root t. And du will be equal to 1 over 2 times root c and dt. Okay? All right? Just to show you why we got this, because the u dt, right? The u dt is equal to 1 over 2 times root c. So we multiply both sides by dt, then we get this piece. All right? So just in case anybody asks that question. All right. And then we are almost there. We're almost there because from this part, okay, from this part, I'm going to copy and paste here. All right. Oops. On this part, of course, this is a u, right? Root t I can show you this way. All right, we can write it that way. And dt over root t, dt rule over root t, and we can solve for it. That's 2 times du. Okay, so from here, you will be able to solve by, in this relationship, you will have 2 times du equals to dt over root t. All right? By this time, we can do the substitution. dt over root t, that's going to be 2 times root t. The key in showing work is that I like to emphasize that you want to show your work either entirely in one variable, always, okay, always entirely in one variable. And here we can bring out the 2 to the front, okay? And this is a cosine u, okay? And then we're gonna go ahead for the antiderivative. So this one, the antiderivative cosine u is sine u and plus the constant. Okay, so in the end, we are getting 2 times sine of root t plus the constant. That's the constant. All right, okay, so we're going to see some other examples. Okay, the question gets a little bit harder. It gets a little bit harder. Okay, so let's look at question number 8. Let's look at question number 8. Okay, how are we going to introduce the u? Okay, feel free to experiment on your scratch paper. If it works, it works. If it doesn't work, try something else. All right, so in this case, we got root z multiplies root z minus 1 dz. Okay, so let's try to introduce u, okay, equals to z minus 1. Okay, in that case, of course, we got du equals to dz, right? The same thing. But how do we express root z, right? So here we can introduce. All right, so I'm going to show you a couple of things. It may or may not work, okay? If it doesn't work, we just try something else, okay? So this is a u, right? And dz equals to du. So this is going to be du. And the question is how we're going to handle root z, okay? So what we can do here, because this piece is not expressed entirely in terms of u yet, right? So what we can do is from here, we can solve for z. Z is equal to u plus 1. U plus 1. So root z is going to be root u plus 1. Okay, so this is going to be u plus 1. But we didn't change the nature of the question. We did not change the nature of the question. Can we integrate this one, right? Does it work? Does this method work right now? Right? That's the question. It looks like we still don't have a solution. So this way doesn't work. This way doesn't work. So if it doesn't work, what do we do? Okay, if it doesn't work, what do we do? I just double checked the question that I think I copied the wrong question. Okay, this should be Z. So this way it should work. Okay. So we still introduce U equals to Z minus 1, du equals dz, and this Z will be equals to U plus 1. Okay, so this Z will be replaced by U plus 1. All right. I made a copy error, right? For these academic questions, sometimes if we don't copy the question right, sometimes you may not get the answer easily. Okay, I'm not saying, of course, there are answers. Sometimes we may use our method and doesn't get it. Okay, so be very careful to make sure we copy the question correctly. All right. So let's look at this one. We've done the substitution, dz, du, root u, and u plus 1. So this way, we can we can find the antiderivative now by multiply u with root u with basically distribute. Okay, distribute. So that way, we got a u raised to the power of root u times u, that's the root u to the power of 3/2. And this piece will be, of course, u raised to the power of half. So we can use power rule to finish. Okay. And be very careful when we are working these kind of questions, right? We just apply power rule, and that's going to be 1 plus 3/2 under 1, and u raised to the power of 5/2. And the other one, okay, is 1 over half plus 1 u raised to the power of 3/2. Don't forget the constant here, okay, plus the constant. Simplify, okay, we got, I just want to make sure I'm recording. So this is going to be 5 under 2 u raised to the power of 5/2 plus, and this will be 2/3 and u raised to the power of 3/2 plus the constant. Last but not least, and brings u back, okay, bring u back, which is z minus 1. All the u is replaced by z minus 1. So all the u is replaced by z minus 1. So that completes the question, okay? So we can see this question actually is a little bit more difficult than many of the other questions, the previous 7 questions. All right. All right. I think we're going to continue. Maybe we'll stop after number 10. Okay, I'm going to stop after number 10. So let's look at number 9. Substitution method. Okay, in this question, you can see that the typical substitution is that you try to simplify the part that is a bit difficult to simplify. For example, the root, right? In this case, the first thing I would be thinking of is that I'm going to introduce u equals to 1 minus x squared. And luckily, we have, if we do du, we're going to get negative 2x dx. And we have an x here, right? So this way, we will be able to substitute pretty quickly. in terms of u. All right? Okay. So let's line up. Okay, so I like to line things up. I like to line things up. So this part is going to be root u. Okay. And x times dx, I'm going to bring them together. Or you can bring them together. You don't have to do it explicitly. So x times dx equals to negative half du, right? So this piece, you're going to replace this by negative half. Negative half is a constant and du, right? And then we are almost there. We are almost there. The integration of root u, we've done it many times, right? We've done it many times. So we just I'm just going to copy and paste this piece. Right? I'm just copy and paste that piece. I have a negative half in front of it. That was what we had before, right? And plus the constant. All right. And now this will be 3/2. So this is going to be 3/2. And sorry, plus constant. And then reduce it. 2 and 2 reduce. So we got negative 1/3. Replace u by its equal. Boom. All done. All finished. Last one for this recording, number 10. Number 10. Of course, we're not going to FOIL, right? This would be too complicated. So in this case, the substitution will be perfect. Okay, so u equals to 5 minus 3x, right? So du equals to negative 3 dx. You can see du and dx has a relationship. And as we substitute, right, and this is going to be u. And dx is a negative 1/3 of du, right? So it's going to be negative 1/3 of du. Substitution is done. And next, we just find the antiderivative of u raised to the power 10. So that's going to be 1/10 plus 1, which is 11, u raised to the power of 11 plus a constant. Okay. This is 11. So 1/11 times 1/3, that's going to be 33. There's a negative sign in front of it, and replace u by its equal. You can have more. You can show more steps, or you can show this condensed step. Okay, so this is a preferred way. We like to see your work. Okay, so there's a nice arrangement of work shown on your paper. Okay, thank you for watching. I will be making another one. Okay.